Hello, my name is Aksha Kikani and this is my Task5.1p demonstration for C language essentials inheritance. In this project, I have implemented several object-oriented programming concepts including inheritance method, overriding, polymorphism, method overloading, and access modifiers. Before running the program, I will explain the structure of my solution and how these concepts have been implemented. I will start with the animal class. Animal is the base class. Animal is the base class or a parent class in my program. This class contains attributes that are common to all animals such as name, diet, location, weight, and age. Since every animal shares these characteristics, they are defined once in the parent class and reused by all child classes. This helps reduce code duplication and improves maintainability. And the animal class also contains methods such as sleep, eat, make noise, and move. These methods are declared using the virtual keyword. Virtual methods are important because they allow child classes to override the default behavior and provide their own implementation. This is the foundation of runtime polymorphism. Now I will move to feline.cs program. Here feline inherits from animal. This means it automatically receives all properties and methods from the animal class. And here I have overridden the sleep method. This demonstrates method overriding because the inherited method behavior has been customized for feline animals. This also demonstrates multi-level inheritance because classes such as tiger and lion inherited through feline. As I have already mentioned here, public override void sleep. Now I will show bird.cs program. Here the bird class also inherits from animal. In addition to inherited functionality, bird introduce a new virtual method called fly. By making fly virtual, different bird species can provide their own implementation of flying behavior. Now I will show a tiger class program. Here tiger inherits from feline because feline already inherits from animal, and tiger gains access to all functionality from both the classes. So here is the example of multi-level inheritance wherein tiger overrides make noise, eat, and move. Instead of using the generic animal behavior, tiger provides behavior specific to a tiger. This demonstrates runtime polymorphism because the method that executes depends on the actual object type. Now here in a wolf.cs program, wolf directly inherits from animal. It overrides methods such as make noise, eat, and move, same as above. This demonstrates that different child classes can provide different implementation of the same inherited methods. Even though the method names are identical, the output changes depending on the object. Here I'll show the lion.cs program. Lion inherits from feline. Similar to tiger, it overrides make noise and eat. This shows how multiple child classes can inherit from the same parent while still behaving differently. Lion inherits from feline. Similar to tiger, it overrides make noise and eat. This shows how multiple child classes can inherit from the same parent while still behaving differently. Now I will show the eagle program. Here eagle inherits from bird. Eagle overrides make noise, eat, move, and fly. This allows eagle to provide behavior that is unique to eagles. The fly method demonstrates overriding of a method that was originally introduced in a bird class. Now I'll show a penguin program. Here penguin also inherits from birds. However, penguins cannot fly. Therefore, I have overridden the fly methods and replaced the behavior with a message explaining that penguins can swim instead. This demonstrates how overridden allows specialized behavior for different objects. Now it comes overloading program. I'll explain method overloading. In this class, I have created two methods with the same name, display. The first method accepts only a name parameter and the second method accepts both name and age parameter. Since the parameter lists are different, the compilers can determine which version of the method should be executed. Here this is known as method overloading and represents compile time polymorphism. Now I'll show a zoo park program which is a main program. In this main method, I created objects for tiger. I will now explain the main program. In the main method, I create objects for tiger, wolf, eagle, lion, and penguin. Each object is created using its constructor and initialized with specific values. Creating separate objects allow us to test the inheritance hierarchy and polymorphic behavior. After creating the objects, I call various methods such as make noise, eat, sleep, move, and fly. Although these methods have the same names across multiple classes, the actual implementation that executes depends on the object's class. So this is a runtime polymorphism in action. Now I will run the application to verify the functionality. The output confirms that each class executes its own overridden methods. For example, the tiger produces a roar, the wolf howls, the eagle flies, and the penguin displays a message indicating that it cannot fly. This proves that inheritance and method overridden are functionally correctly. We can also see the output from the overloaded display methods, where different parameters list produce different results. Thank you.